Welcome pre-cal students to the homework help video, page 610, 1 through 81, every other odd, and 34, 47, and 67. Let's go ahead and get started with numbers 1 through numbers 1, 5, 9, and 13. The directions say to evaluate the expression without the aid of a calculator. So here we go, students. Let's go ahead and get into this right away. Let me go ahead and get my calculator here. I know we're not going to use it now. Let me get it ready. And here we go. Arcsine of 1/2 is the same thing as, wow, it's not that, that's for sure. Here we go. It's the same thing as sine of an angle equals 1/2. And of course, sine is restricted to quadrant 1 and 4 when you're talking about arcsine. So we want sine of an angle gives us a positive 1/2, so we're going to be in the first quadrant right here. All right, and so we're basically saying what angle gives me 1/2. Okay, and so we should pretty much have that memorized. If you think of 1 and 2, a length of 1 and 2, I'm thinking of a 30, 60, and 90 triangle. And if you draw a 30, 60, 90 triangle and label the sides, you're going to see it's the sine of 30. Okay, the sine of 30 degrees. So theta equals 30, or pi over 6 in radians. All right, number 5, arctangent square root of 3 over 3. So here we go. First of all, we're going to write tangent of theta equals square root of 3 over 3. And of course, when you're dealing with arctangent, you're restricted to quadrants 1 and 4, and we're looking for an angle that gives us out a positive answer, so we know we're going to be in the first quadrant. And so let's see here. We've got to look at our table that we have, or you can also think of a drawing a 30, 60, 90 triangle, and using that to help you figure out what angle, when you take the tangent of it, gives you square root of 3 over 3. And what you should end up with is 30 degrees also for this. So let me show it to you real quick just so we can see this. Here's your 60, here's your 30, here's your right angle, this is 2, this is 1, this is square root of 3. And as you can see, the tangent of 30 would be opposite over adjacent, so 1 over square root of 3. And if you rationalize the denominator, you get square root of 3 over 3. Okay? So theta equals 30 degrees, or pi over 6. All right, moving on. Okay, here we go. Arctangent negative square root of 3. So tangent of theta equals negative square root of 3. So we're dealing with arctangent, so we know we're going to be restricted to quadrants 1 and 4. We want to find an angle that when we take the tangent of it, we get a negative square root of 3, so we know we're going to be in this quadrant right here. Okay, and if you use your 30, 60, 90 triangle, you're going to see that the angle that when you take the tangent of it that gives you square root of 3 is 60 degrees. So in this triangle we put 60. Now you guys are used to then going like this and saying your answer is 300, and that's normally okay. If I had, now watch this, if I had not given this problem to you here, if the original problem had just looked like this, then that's fine. The answer would be 300 degrees. But we're dealing with arctangent, and remember, our answers for arctangent have to be greater than or equal to negative 90 and less than or equal to 90. Okay, so instead of putting a positive 300, we're going to say negative 60 is the answer. Okay, negative 60, or negative pi over 3 in radians. All right, number 13. Okay, arcsine of square root of 3 over 2. Oh, here we go. Sine of theta equals square root of 3 over 2. All right, and so let's see here. We want to realize we're in quadrant 1 or 4. We're going to be in quadrant 1. Okay, and we're trying to find out, when we take the sine of an angle, what angle would give us square root of 3 divided by 2. And of course you can use your table, your chart that you have, or you can draw a 30, 60, 90 triangle, and you will see it is 60 degrees. So theta is 60, or pi over 3. All right, moving on to number 17. And now the directions say use a calculator to approximate the expression, round your result to 2 decimal places. So here we go, this will be even faster. Cosine of theta equals 0.28. So I'm going to hit second cosine, and then 0.28 and hit enter. And I'm going to get 73.739. So 73.739 would round to 73.74 degrees. Okay, I'm not sure if they want the answer in radians or degrees. It doesn't say. So depending whatever mode your calculator's in, my mode right now is degrees. So my answers are coming out degrees. Okay. And let's continue on. Number 21. Let's see, tangent of theta equals -3. So we're allowed to use a calculator. Second tangent, -3, enter. And you're going to get this right here for your answer. -71.565, which means we're going to round the two decimal places like the directions say to do. So -71.57 degrees. All right, moving on to number 25. Arc cosine of -0.41. Well, we rewrite that as cosine of theta equals -0.41. Okay. Then hit second cosine because we're looking for an angle, -0.41. And we're going to get out 114 degrees, 0.204. Okay, so because this 4 here tells us to leave the 0 alone, we're just going to round the two decimal places. And there's our answer. All right. Moving on to number 29, arc sine of 3/4. Well, that means sine of theta equals 3/4. So with my calculator, I'm going to hit second sine, and then 3 divided by 4, or 0.75. That's easier for you. And I'm getting out theta equals 48.590, which means the 0 tells us to leave the 9 alone. So there's our answer, 48.59 degrees. Okay, all right, moving on to number 33. Now this is a pretty cool problem here. See if you can stay with me on this. Okay, students, here we go. Now what they want us to do, stop and think for a second. Okay, they want us to fill in these blanks. In other words, they want us to find the x values here. Okay, when y is pi over 4, find x. Well, I think it would be helpful if we first of all rewrote this function right here, maybe in a way that we understand a little better, like this. Now, first of all, don't let this y confuse you, okay? Remember, let's talk about this for a second. If I just had arc tangent x, you would write tangent of theta equals x, correct? Sure you would. Now, you're assuming the unknown was theta. However, if your original problem starts off with y equals, then what they're telling you is your unknown is y. So when you rewrite this, watch carefully. You don't put tangent of theta, you put tangent of y equals x. So nothing changed here. You're used to putting theta here, okay? But since they're telling you this entire arctangent expression equals y, then y is the angle you're looking for. Okay, so you would just simply rewrite it like this. That makes it a lot easier, doesn't it? Look at this. This is so much easier. Tangent of y. Well, this is your y value here. So we're putting in pi over 4. We're putting in pi over 4. So tangent of pi over 4 equals x. Well, we know pi over 4. That's one of our special triangles. That's 45 degrees. So we have 1 square root of 2. So the tangent of pi over 4 is opposite over adjacent 1. So the tangent of pi over 4 is 1. So when you put pi over 4 in for y, you get out 1. And that looks right, doesn't it? There's your point. It's over 1. Okay, looks pretty good. All right, let's try another one here. Now, we've already rewritten our expression here, tangent of y equals x. Now we're going to put negative pi over 6 in. All right, so here we go. Tangent of negative pi over 6. And don't forget, negative pi over 6 is the same thing as -3 degrees. So here's my special triangle, 30, 60, 2, 1, square root of 3. All right, tangent of 30, opposite over adjacent, 1 over square root of 3, or in other words, square root of 3 over 3. So, and it would be negative, so negative square root of 3 over 3. So here we go. This blank right here, when you put in negative square root of 6, you get out negative square root of 3 over 3. Now, how did I know it was a negative square root of 3 over 3? Well, the quick, easy answer is this. The quick, easy answer is, look, students, look where the point is. I mean, the point is over negative square root of 3 over 3 and down negative pi over 6. Okay? So it was obvious by where the point was that's going to be negative square root of 3 over 3. All right? Now let's take a look at the last problem here. The last point they want us to figure out, and the point is this. Here they're giving us the x value. Look at this. They're giving us the x value. So we're going to say tangent of y equals negative square root of 3. In other words, what angle, when you take the tangent of it, do you get negative square root of 3? Well, that should be on your table. It's one of your special trig function values. And so the tangent of an angle that gives you negative square root of 3 is going to be 60 degrees, negative 60 degrees. So, and I know it's negative because we're over negative square root of 3. Here's your point. We're over negative, then we're down. And the angle that works here is 60 because the tangent of 60 gives you negative square root of 3. Well, tangent of negative 60, sorry. So right here, I would put negative 60. And that's it. These are pretty cool problems. Let's try number 34. Number 34 is pretty much the same, only they're going to give you two x values and one y value over here, but it's still pretty much the same thing. So here we go. Okay, let's go ahead and rewrite this function. Remember, they're telling us that our unknown for arc cosine is y, not theta. So when we rewrite it, we're going to put not cosine of theta, but cosine of y equals x. Okay. Now let's start up here, I guess. Why not? This is your x value. So for x, I'm going to put negative 1. So cosine of y equals negative 1. So what angle, when you take the cosine of it, gives you negative 1? Well, it's going to be one of your quadrant angles. Okay. And so I'm quickly going to type in my calculator cosine of 0. Did not work. Cosine of 90. Did not work. Cosine of 180. Did work. So there we go. So the angle when you take cosine of it is 180 degrees, or dealing with radians, pi. So you can put pi here if you want. I would put pi because your y-axis here is in radians if you'll look. Okay, so the angle when you take the cosine of pi, you get negative 1. All right, now let's go on to our next ordered pair, which is right over here. And we're going to put negative 1/2 in for x. All right, so here's my x value right here. I'm going to put negative 1/2. So what angle, when I take the cosine of it, gives me a negative 1/2? All right, and that should be on your table that you use, or your special triangles, your 30, 60, 90 triangles. You'll see it's going to be, well, it's going to be 60 degrees. However, be careful, students. Please be careful here, okay? On your table, it shows you that when you take the cosine of 60, you get 1/2, but we're dealing with negative 1/2, so don't forget that would put you in the cosine is this quadrant or this quadrant, so we're right here. So if you put a 60 here, then the angle you're looking for is 120 degrees. So the cosine of 120, and if you don't believe me, you can try this. Type this into your calculator, okay? But the cosine of 120, or what would that be in radians? Let's see, we're 60 short. That's 30. I mean, it's 3, so it should be 2 pi over 3. Okay, the cosine of 120 degrees or the cosine of 2 pi over 3 does give you negative 1/2. So for your answer here, you can put 120 degrees, or you could put negative, or not negative, just 2 pi over 3. All right. Okay, let me get a drink here, and we'll continue on. Okay, now, if you'll notice, they're giving us a y value for our last ordered pair. All right, a y value. So, where the y is, I'm going to substitute pi over 6, so the cosine of pi over 6 equals x. And pi over 6 is the same thing as 30 degrees. So very quickly I can do this. Boom, boom, there we go. 30, 60, 2, 1, square root of 3. The cosine of 30 would be adjacent over hypotenuse. So square root of 3 over 2. Just like that. Boom, we're done. So the cosine of 30 degrees is square root of 3 over 2. So that's what you would put right here. Square root of 3 over 2. Pretty cool. Okay. All right. Moving on now to number 37. For numbers 37 and 41, the directions say to use an inverse. Let me pull my book here a little closer, guys. Hold on one second. All right. Use an inverse trig function to write theta as a function of x. So here we go. First of all, you realize here's theta. Second of all, you realize you're dealing with these two sides. So based on theta, let me change colors here. I think green will show up a little better. Based on theta, we call this your opposite side, and we call this your adjacent side. Okay, so we're going to deal with tangent. Okay, so tangent of theta equals opposite over adjacent. Now, the directions say to write an inverse function, write theta as a function of x. So, remember what we learned back here in this problem. Usually, arctangent is going to equal theta. Okay, so usually you can put theta right there, but in these problems it was y. Well, in this problem here, we have theta right here, so we're welcome to write arctangent of what? X over 4 equals what? Theta. There we go, we did it. We wrote theta as a function of x, or theta in terms of x. Not too hard. That's it. Because listen, students, let me erase this real quick. Look, watch this, please. Forget everything up here except this right here. If I gave this problem to you, you would rewrite it like this. You would write tangent of theta equals x over 4. And you would assume that the angle you were going to use was theta. So in other words, this entire expression equals an angle. This entire expression equals theta. Okay? All right. And we know that because of the angle they gave us right here. If this angle right here would have been y, then we put a y right here. Okay? All right, continuing on to number 41. Okay, here's theta. So we call this side here adjacent, and we call this side here hypotenuse. So with that in mind, we know we're going to use adjacent. We're going to use cosine. So cosine of theta equals adjacent over hypotenuse, x plus 3 over 2x. And now we rewrite it so that theta is all by itself. So we're going to write arc cosine of x plus 3 over 2x equals what? Well, what's your unknown right here? Equals theta. There we go. You just wrote theta as a function of x, or theta in terms of x. Okay? Alright, moving on to number 45. The directions say to use the properties of inverse functions to evaluate the expression. So here we go. First of all, we start inside the bracket here, this part right here, and we're going to bring down the cosine, and on the inside right here we're going to write cosine of theta equals negative 0.1. Okay? Now, let's think this through for a second, students. Whatever I get out for theta here, if I were to take, and I know how to do this, I'm just trying to think of the best way to explain it, okay? If I were to use my calculator and hit second cosine and get out some angle, I'm going to go ahead and do that. I'm going to hit second cosine of negative 0.1 and hit enter. Now I'm getting this. Watch. I'm getting negative 5.73917.048. But what I'm going to do, students, is I'm going to leave this on my screen. Okay, so leave this on your screen because now that I've worked this out right here, and I got this angle right here, now the next thing I have to do is I have to take the cosine of this angle. So I'm going to leave this angle right here on my screen, and I'm going to hit cosine of that angle. In other words, cosine and then answer. If you'll look at the very bottom row, not column, if you have a TI graph, look at the very bottom row, look at the button right beside the enter button. It's a negative sign right above that. It says answer. So if you'll hit cosine and then second negative, up will pop the answer, okay? And then hit enter. And you should get negative 0.1 back out. And that makes sense, guys. Think about it. You're saying the cosine of what angle will give me negative 0.1, and then whatever that angle is, I'm going to take the cosine of that angle, and it should give you write back out negative 0.1. Okay, now don't assume, students, please listen to me. Don't assume because you see cosine and then arc cosine, the answer will always be this. Some of them will be undefined or no solution. And I won't get into why now, but that happens sometimes. So always work them out, okay? All right, number 47. All right, now we're going to start off by taking the sine of 3 pi. Okay, so here we go. Sine of 3 pi, that would be the same thing as, let's see, 540 degrees. So we're taking the sine of 3 pi or the sine of 540 degrees. Now if you think about it, that's going to be one rotation and then more. It stops right here. So it's one of your quadrant angles. So we're going to use a calculator real quick, and we're going to type in the sine of 540 or the sine of 3 pi, and you're going to get out 0. So when you take the sine of 3 pi right here, you get 0. So now I have arc sine of what? 0, because sine of 3 pi was 0. So now I'm going to write sine of an angle equals 0. Now be careful. Don't put 3 pi. Let me explain to you why. Remember, whenever you're trying to find the angle for an arc sine, your theta has to be in between negative 90 and 90, or negative pi over 2, which is the same thing as 90, and positive pi over 2. All right, so when I'm saying to you the sine of some angle equals 0, we got to remember sine is restricted to this quadrant here and this quadrant here. So I'm going to try 90, I'm going to try 0, and I'm going to try negative 90. See what I get. So the sine of 90 gave me 1. The sine of 0 gave me 0. Cool, so that works. So theta equals 0. I'm going to go ahead and try negative 90. I don't think it's going to work. I'll go ahead and try it. Sine of negative 90 is negative 1. So there we go. Let's try this again real quick. Okay, the sine of 3 pi, or 540 degrees, is 0. So for this entire parentheses here, I put a 0. Then I brought down my arc sine. Then I said, okay, arc sine of 0, so sine of theta equals 0. So I knew that my answer had to fall somewhere between these two quadrants, okay, quadrant 1 and quadrant 4. So, using my calculator, I tried 90, 0, and negative 90, and 0. Sine of 0 gives me out at 0. Okay, all right, moving on to number 49. All right, find the exact value of the expression. So here we go. All right, let's start off with arc tangent of 3/4. That means the tangent of theta equals 3/4. So we'll come over here. We want to take tangent of an angle that gives us out a positive 3/4. So we know we're going to be in this quadrant here. Opposite over adjacent. So using Pythagorean's theorem, this will be 5 right here. And now we have totally defined theta. Theta is this triangle, this angle here in this triangle. So now we just take sine of theta, and sine of theta would be opposite over hypotenuse. So the answer is 3/5. All right, moving on to 53. Okay, on the inside here we have arc sine of 5/13. So that would be the sine of theta equals 5/13, and we know sine is restricted to here and here. We want an angle that gives us out a positive 5/13, so we'll be in the first quadrant here. Opposite is 5, the hypotenuse is 13. Let me grab my calculator real quick. 13 squared minus 5 squared, square root of that would be 12. So if you use Pythagorean's theorem, you will get a 12 here. So now we have our triangle and our theta totally defined. So now here's our cosine. So now we simply take the cosine of theta, and the cosine of theta would be adjacent over hypotenuse. So 12/13. Okay, cosine of theta would be 12/13. So moving on to number 57. All right, arc cosine of negative 2/3. So cosine of an angle would give us negative 2/3. Now cosine, don't forget, is restricted to this quadrant here and this quadrant here, and we want an angle that when we take the cosine of that angle we get negative 2/3. So that would put us in this quadrant here. So theta's here, and cosine of theta would be adjacent over hypotenuse. So we should get square root of 5, I believe. Let's see, 9 minus 4, yeah, square root of 5. So okay, we've defined theta, we've drawn our triangle here. Now we're going to bring down our sine right here, and we're going to find the sine of theta. And we can do that, the sine of theta. All right, so the sine of theta. What is sine in this quadrant? Well, the sine sequence go positive, negative, negative. So sine is positive. So the sine of theta will be positive opposite over hypotenuse. There it is. Positive square root of 5 over 3. Okay, moving on to number 61 here. The directions say write an algebra expression that is equivalent to the expression. Alright, so here we go. We're going to write an algebra expression. So let me move some stuff here real quick. Stretch my legs, and let's go ahead and get started. Here we go. Okay, arc sine of 2x, well, that's the same thing as the sine of theta, equals 2x over 1. Okay, so sine would be in the first quadrant because 2x over 1 is positive. So we have opposite over hypotenuse. Now using Pythagorean's theorem, we have one leg here. I'm just going to call it L for leg. So I have a leg squared plus my other leg squared equals the hypotenuse squared. That would be leg squared plus 4x squared equals 1. Then bring this term over, so L squared equals 1 minus 4x squared. Then take the square root of both sides, and we get the square root of 1 minus 4x squared. Okay, so there is the entire leg right here. Alright, let's try that again. Here we go. Now, let's see what's left for us to do. They want us to take the cosine of theta. Remember, students, once you work out the entire arc sine and get it defined over here, we can now just use theta for this parenthesis. So we're going to put cosine of theta equals, and here's cosine of theta, adjacent over hypotenuse. So square root of 1 minus 4x squared, that's adjacent all over 1, or in other words, just this. Now, I know in the back of the book they put something like x has to be greater than this number or less than this number or something like that, but listen, this is good enough for me. I'm going to very quickly show you why they have a domain for this. Okay, what you do is you take this expression here under the radical, and once again, students, let me say this again. Let me get a drink here. Listen, this answer here is totally sufficient. You are done. You are finished. That's great. Okay, but let me very quickly show you where you got the domain from. They took 1 minus 4x squared. They said equal to 0, and they solved. Bring the 1 over, make it a negative 1, so negative 4x squared equals negative 1. Then divide by negative 4, so x squared equals 1/4, because a negative 1 divided by a negative 4 is a positive 1/4. Then they took the square root of both sides, so the square root of x squared is x, and the square root of 1/4 is 1/2, because 1/2 times 1/2 is 1/4. So, and then what you do is you put a 0 here, a 1/2 here, plus minus negative 1/2 here, and then you test numbers in this quadrant. You test numbers in this region, and you test numbers in this region. So over here I would test negative 1. So if you put a negative 1 in here for x, negative 1 squared is 1 times negative 4, you get out negative 3. You get out the square root of negative 3. That's not going to work. Then you put 0 in for x, And 0 does work. 0 squared times 4 is 0. 1 minus 0 is 1. So you get square root of 1. That works. And then over here you test 1, positive 1. Put a 1 in, it's 1 times 4 is negative 4. You end up getting square root of negative 3. So the domain the domain, students, they use is this region right here. So they say the answer is the square root of 1 minus 4x squared as long as x is less than or equal to 1/2 and greater than or equal to negative 1/2. But you do not need to do that. Okay, all right, moving on to number 65. Okay, arc cosine of x over 3, that's the same thing as cosine of theta equals x over 3. Okay, so here we go. Cosine would be in the first quadrant. Put your theta here. And adjacent over hypotenuse. So let's quickly find our missing leg right here. We're going to say our missing leg is leg squared plus my other leg squared equals my hypotenuse squared. So leg squared plus x squared equals 9. Bring the x squared over and make it negative. L squared equals 9 minus x squared. Take the square root of both sides, and L equals the square root of 9 minus x squared. Now again, students, I'm not going to go into detail as to where they get their domain for this, okay? But the square root of 9 minus x squared is your missing leg, okay? So let's go over here. Let's grab this. If I can get it to work here. Maybe I can't. Let's start up here. It's not going to work, so we'll just draw it up here. Here's your missing leg, and the square root of 9 minus x squared. Okay, so we now have labeled the missing side of the triangle. So now what we're going to do is this. We're going to take the tangent of theta, which is opposite over adjacent. So the answer would be the square root of 9 minus x squared all over x. There we go. There's your algebra expression. Okay, moving on to number 67. Let's see what we have here. All right, let's start with inside the parentheses first. So we have tangent of theta equals x over square root of 2. So here we go. Draw our triangle here. Here's theta opposite over adjacent. Okay, so one leg is the square root of 2. The other leg is x equals hypotenuse squared. So when you square the square root of 2, you get 2. When you square x squared, you get x squared. And now take the square root of both sides. So the square root of 2 plus x squared equals 8. Now a lot of students right here, they want to take the square root of x squared and put an x on the outside, but you cannot do that because you have two terms here inside the radical. Okay, so you cannot do that. So you must just leave it. You have to just leave it square root of 2 plus x squared. All right. So having done that, now here's what we're going to do. We're going to bring down our cosecant, and we're going to take the cosecant of theta. All right. Now, cosecant of theta would be the reciprocal of sine, and sine is opposite over hypotenuse, so cosecant would be hypotenuse over opposite. Okay. So your hypotenuse is square root of 2 plus x squared, and your opposite would be x. So there you go, students. There is your algebra expression. Okay, all right, moving on now to number 71, I believe it is 69, number 69. All right, students, number 69. Now, I did not mean to put number 69 on here, and to be honest with you, my voice is starting to go here a little bit, so let me kind of talk quietly. Students, I really need to come in some days and work with you guys on your graphing calculators. I did not mean to put 69 on here. I know totally how to do this. The complicated part to doing number 69 would be the viewing window. knowing how what to make your your x minimum and your x maximum and your y minimum and your y maximum. Okay, so I did not mean to put this on here. I apologize. We need to do this sometime, but it will not be today, nor will it be on this homework problem here. Okay, let's continue on to number 73. Okay, number 73. Now, on 73, let's do this first of all. On 73, let's first of all take a look at this left side over here, okay? Right here. The arc cosine. Now, we understand that means, hold on one second here, the cosine of theta equals 3 over the square root of x squared minus 2x plus 10. Okay? Now, real quick, down here, I'm going to go ahead and do my usual triangle drawing, okay, like this. I'm going to put theta here. I'll make the triangle kind of big because we got some big expressions here. Now, adjacent would be 3, and the hypotenuse would be this right here. Now, let's find this missing leg. So I'm going to put leg squared plus my other leg squared equals, and then I'm going to square this entire square root, okay? Now watch this carefully, okay? Leg squared is leg squared. 3 squared is 9, and you should know by now that whenever you square a square root, you get just what's under the square root, like this. Okay, now we're going to bring the 9 over and make it a negative 9. Okay, so bring it over, make it a negative 9, and we're left with L squared equals x squared minus 2x plus 1. Now students, watch this carefully. This is really cool how this works, okay? When we go to take the square root of both sides, look what we have. The square root of L squared is L. However, the square root of the right side would be this right here, the square root of x squared minus 2x plus 1. Now you think you're finished, but hold on, watch this, okay? Well, I shouldn't have done that. That was a mistake. There we go. Now when you go to finish finding the leg, watch this carefully. This is really cool how this works, okay? Now look. You can factor this trinomial, so you get this. You get the square root of, watch, x minus 1, x minus 1. Now that's why we spent the first week going over factoring. I'm not going to explain where that came from, okay? But x minus 1 would be the same thing as x minus 1 squared, okay? And the square root of a quantity squared is just itself, so the leg really equals x minus 1. Pretty cool. Alright, so there we go. Alright, now having done that, think about this for a second, students. We're saying this, what arc cosine. Now remember, anytime you take the arc cosine of something, the entire expression is really an angle, usually theta. So this whole side over here is theta, okay? And now if I take the sine of opposite over hypotenuse, so x minus 1 over the square root of x squared minus 2x plus 10, like this, then I also get the same theta. Because look, students, cosine of this theta here gives me this, and sine of this theta here gives me this. So this is what I have to fill in the blank with. Okay, these are a little tough to see, but hopefully you're doing okay with this. Okay, now students, let me say this. My voice is really getting rough. So I'm going to go ahead and pause the video. I'm going to go ahead and stop the video. And the other problems left are 77, 70, 81, 77, and 81. Those are our last two. So just two left. But my voice is really going out. So here's what we're going to do. I'm going to go ahead and stop the video. And the other video that you're going to watch is going to be called, we're going to call it October 1st Homework Part 97. Just kidding. Part 2. Okay, so this video now is done. Go ahead and look for this video next to watch the last two problems. Okay? All right.